everyone, this is Mrs. Basilise. Welcome to our first expanded pre-algebra video, starting chapter 1, which is titled Variables, Expressions, and Integers. And more specifically, we're working today on 1.1, 1.2, and 1.3, which is going to cover basically variables and expressions, and we're also going to cover the order of operations. So let's go ahead and get started. Alright, let's get started with section 1.1, expressions and variables, and let's look at the vocab. I want you to note that there are 2 times where the word expression comes up. An expression has an operator in it, like adding, subtracting, multiplying, and dividing, and all the other operators out there. But there's 2 different kinds of expressions. There's a numerical expression, and there's a variable expression. And it seems pretty self-explanatory that a numerical expression has numbers, like 4 plus 5, where a variable expression has variables, like x plus y, or even x plus 5. As long as it has a variable in it, it's called an expression. But very important to note that an expression is not an equation. Why do you think? Why isn't an expression an equation? Maybe because they don't have equal signs. So expressions do not have equal signs. If they did, they would be called equations. And since they do not have equal signs, they cannot be solved, but they can be evaluated. So we basically are finding the value of expressions. We don't really solve them, we find the value of them. So if I wanted you to evaluate this expression, lost my pen. Come back, pen. There we go. If I wanted you to evaluate the expression 30 plus 15, you would be giving me the value of 45. That's evaluating. A variable is a letter that takes the place of a number. Any letter will do for a variable. And the verbal model is when you take an English sentence and translate it into a math problem, whether it is a math expression or a math equation. In this chapter, we're going to be working with expressions. Let's see some practice problems now. So here we have an evaluation practice problem. Notice how it says not solve, but it does say evaluate the expression xy when x equals 6 and y equals 12. One thing I want you to note, this expression right here, xy, that is a variable expression. I don't know why my handwriting is not cooperating here. There we go. And what we're going to do here with that is we're going to take that variable expression, which is xy. We're going to plug in the values. Oh, first of all, before we plug in the values, I want you to know, what are x and y doing with each other here? They are actually multiplying. So this is a variable expression where the 2 variables are multiplying with each other. That means that their actual values, which are 6 and 12, will be multiplying with each other. If I don't put that multiplication symbol in there, it's going to look like 612. And that's not really what's going on here. What's really going on here in this variable expression is that x and y are multiplying. So we end up doing 6 times 12, which is 72. And we have evaluated the expression xy when x equals 6 and y equals 12. Our next example is for writing a verbal model. I'm going to go ahead and read the problem with you. It says, in 2002, astronauts Carl Waltz and Dan Bursch spent 196 days in orbit. How many sunrises did they see? Before we can answer the question of how many sunrises they saw, we need a little bit more information. So let's take a look at number 1. It says, an astronaut, any astronaut, in orbit circles the Earth every 90 minutes, and they see 16 sunrises each day. Let D be the number of days any astronaut is in orbit. Write a variable expression for the number of sunrises seen in D days. Okay, so we almost kind of have to let go of that 196 part, the part where it said 196 days at the beginning, because we're going to build up to that answer. So they see 16 sunrises each day. Let me get my pen. They see 16 sunrises each day, and D is the number of days in orbit. Each is a word that represents multiplication. because if they see 16 sunrises in one day, that means they see 16 times 2, 16 plus 16 sunrises in 2 days, 16 plus 16 plus 16, or 16 times 3 sunrises in 3 days. So if it's D days, it's 16 times D, or we can just say, it's kind of hard to write and stay on the camera at the same time, so I'm going to kind of disappear for a second. We can say 16D. That's our variable expression for the number of sunrises seen in D days. To identify the value of D for Walt and Birch's 2002 space flight, well, that information is at the beginning. The value of D was 196 because they spent 196 days in orbit. So to find the number of sunrises, we're going to want to evaluate, and we're going to take 16D, and instead of D, we are going to write 196 and multiply to find the number of sunrises Walt and Birch saw. All right, now we are ready for 1.2 and 1.3, powers and exponents, and I went ahead and included the orders of operation or order of operations in here because exponents is one of the order of operations. So, PEMDAS, very popular PEMDAS, but I like to write it P-E, well, let me get my little guy out here, here we go, P-E-M-D next to each other and A-S next to each other. Almost looks like a game of hopscotch here. If you don't know what hopscotch is, Google search it and you'll find out. Why do you think I wrote M and D next to each other and A and S next to each other? Well, I did that because multiplication and division, if they are in the same problem and next to each other, they must be done from left to right. Multiplication does not get done before division or vice versa if they are next to each other. So for example, if we have a problem like 5 divided by 1 times 2, we don't multiply first. We just divide and multiply from left to right. Next, same with addition and subtraction. That's why I have them next to each other. So what is the order of operations? It is a set of rules developed to have a consistent order for evaluating expressions. If we all evaluate expressions the same way, we'll always get the same answer. If we all choose our own order of operations, we will not always get the same answer. P stands for grouping symbols. I know it's P, but it really stands for grouping symbols, but PEMDAS sounds so much better than GEMDAS, but I guess we could use GEMDAS if you really want. But P stands for grouping symbols. Grouping symbols could be parentheses, brackets, braces. Fraction bars are actually grouping symbols. Later on you'll learn that square roots and any radical sign is a grouping symbol, as well as absolute value symbol, absolute value sticks. E stands for exponents. M and D, multiplication, division from left to right. A and S, adding and subtracting from left to right. If you do not know what exponents are, here's how we work with them. Exponents have a base, which is your big number, and an exponent, which is your little guy, base, exponent, also known as the power. The exponent tells you how many times to multiply the base to itself. So this is a form of repeated multiplication, and this is telling me not 6 times 3, but 6 times itself, 1, 2, 3 times. And before we move into actually evaluating using the order of operations, I'd like to review again the difference between evaluate and solving. Evaluate means we find the value of something, so we're looking for the value of the expression. So I just kind of hinted to the next one. We evaluate, or you evaluate, expressions. See, since I'm left-handed, I can't rest my wrist, so my handwriting doesn't look so pretty. I'm sorry. I really have nice handwriting. We evaluate expressions and we solve equations. You evaluate expressions and you solve equations. These are lefty problems, people. Lefty problems. All right, we evaluate expressions, we solve equations. Expressions are either numerical or they are variable. And then you can go ahead and answer how expressions are different than equations. But one thing I want you to take note of is that we can evaluate numerical expressions, no big deal. But we can only evaluate variable expressions when we are given we have to be given the values of the variable like we did in 1.1. So it's time to try some examples. And let's see if my my handwriting here works out. So we've got 28 minus 63 divided by 7. According to the order of operations, division will go before subtraction. So we are looking at 28 minus 9. 63 divided by 7 is 9. And 28 minus 9 is 19. Now, I'm working here without the use of a calculator, and you should be also working without the use of a calculator. Please feel free to correct me if I make any mathematical errors, because I'm trying to do all this videoing in one take without much editing. Okay, so let's take a look at the next one. In the next one, we're going to want to do 12.5 or 12.5 times 4 first, because multiplication comes before addition. So we are going to do 52 plus 12.5 times 4, which is 50. And add those together to get 102. In the next problem, I'm just going to go ahead and mark the ones that we would do first. We would do 9 times 6 first, followed by 27 divided by 3. Take those results and add them together. I'd like you to go ahead and pause the video to try number 4, number 5, and number 6, and then play the video so that you can see the answers. Okay, here are the answers. I changed the pen colors a little bit just for fun. Number 4, I went ahead and added in the grouping symbol first, 1.5 and 0.6 to get a 2.1. Multiplied 2.1 by 10, which makes it bigger by 1 loop, and gives me a 21. Number 5 shows a fraction bar as a grouping symbol, which means it separates the top from the bottom. That's what that grouping symbol does. So that means you solve the top. I'm sorry, I said solve. You evaluate the top, which is 60.8. You evaluate the bottom, which is 8, and then you end up doing the division, 60.8 divided by 8, to get 7.6. So there's an example of a fraction bar as a grouping symbol. In the next one, we have a few operations in here. First, I went ahead and took care of this grouping symbol that's inside of yet another grouping symbol. So inside grouping symbols, we also have to follow the order of operations. So I took care of 11 minus 7 first to get the 4. Notice how I kept my brackets, just to show that I wasn't quite finished with the bracket yet. Took the 4, multiplied it by 2. Let me get my little pointer here. Took the, I like this one. Took the 4. Whoa, did you see that? It's a lightsaber, guys. Check that out. Took the 4, multiplied it by 2, got the 8. 72 divided by 8 makes a 9. I did not know that was going to be a lightsaber. That is the order of operations. So what we're going to do now is practice an evaluation problem with variable expressions in which we need to plug in some values and then do the order of operations. So let's check a couple of those out. All right, take a look at these beauties. We've got 6 problems here. Notice how all of these are variable expressions. Get our lightsaber back. These are all variable expressions. We wouldn't be able to really do anything with these unless we had the values, which we do, right? Lightsaber, there we go, which we do, right there. So this is a matter of doing what I like to call plug and chug. I don't know why I call it plug and chug, but I do. You plug in the values, you chug out the answer. So I'm going to do a couple of them. Let's see, which ones do you guys pick? See if I can read your mind. I'm going to pick number 10, and I'm going to pick number, I'll do 3 of them. I'll do these 3, and then you guys can work on your own on these. So let's go ahead and plug and chug. We've got 0.5 bracket y, which is 2, minus parentheses x, which is 4 minus 2. All right, so now we have to evaluate this problem. We got to work inside the bracket first, and then also work inside the parentheses, which is inside the bracket. So that is going to be another 2. And I didn't want to make that just the 2. There we go. So that gives us the 4 minus 2, which is 2. Oh, this is going to be an easy one, guys. See if anyone can see what's going to happen. We've got 0.5 is multiplied to whatever 2 minus 2 is, which is 0. And anything times 0 is 0, so the answer to this guy is 0. Let me double check my work. Make sure I plugged in correctly. To plug in correctly, we got to make sure that the y is 2. Yep. 4 is x. Yep. Perfect. Let's try the next one. X squared, so 4 squared minus y, which is 2. 4 squared, that's 4 times 4. Just to refresh your memory, that is not 4 times 2, but it is 4 times 4, which is 16 minus 2, which is equal to 14. That's a little bit different from the next one. In the next one, we've got 2, and 2 is multiplying to x minus y squared. So 2 is multiplying to 2 squared. Careful here. Careful here. Remember, the order of operations says you do exponents before you do multiplication. So we have to do the exponent because technically that guy right there, he's not really a 2. He's a 2 squared. So technically, he's a 4. And he gets multiplied to 2. Which results in an 8. So now we're done. That is 1.1, 1.2, and 1.3 of Chapter 1. I hope that you were able to learn a few things and get your confusions taken care of, and we will review some more in class tomorrow. Bye-bye.